Aviation has played a vital role in much of American and world history by moving people from place to place, delivering goods, bringing soldiers to and from battle, and exploring the universe.
Are the Wright brothers famous for pioneering flight in America?
Yes, the Wright brothers' flying machine took off at the beginning of the 20th century. Now we fly around the world giving little thought to the ingenuity, creativity, innovation, and engineering skill required to design a plane to do what it does. Aeronautics, quite simply, is the science of flight, which also involves the study, design, and manufacturing, or the techniques of operating aircraft and rocketry within the atmosphere. Any vehicle that flies through the air or space is considered an aircraft. This includes helicopters, airplanes, and space vehicles, such as the SpaceX Dragon and the retired NASA space shuttles. Aeronautical engineers must study 4 basic areas in order to design planes and other flying machines: aerodynamics, propulsion, materials and structure, and stability and control. Aerodynamics is a branch of physical science which deals with the motion of air and the way it interacts with moving objects.
Is this the science that studies how air flows around the wings and other parts of an airplane?
Yes, by studying the way air flows, engineers design the wings, tail, and the main body or fuselage of an airplane so that it will fly efficiently. Propulsion is the force that moves something forward. In aeronautics, the study of propulsion is what helps engineers determine the appropriate type of engine and the right amount of power required to create lift. Materials and structure technology is critical in the design and creation of vehicles that are strong enough to fly efficiently.
Have scientists been finding lighter materials to build airplanes with?
Yes, many airplane parts are now made out of composite materials, such as carbon fiber, that are lightweight yet stronger than most metals. The last area, stability and control, is the study of how to control the speed, direction, altitude, and other aspects that affect how a plane flies and operates. Aeronautic engineers design the controls and cockpit that pilots use to correct and maintain the stability of the plane during flight. The first widely used passenger jet was the Boeing 707, a narrow-body, 4-engine, long-range aircraft introduced in 1958. Not only did this plane revolutionize airline travel, it also laid the foundation for Boeing's steady growth in the jet airliner market. More recently, Boeing introduced the 787 Dreamliner, a spectacular achievement that truly represents the state-of-the-art in aeronautics. Improved aerodynamics, advances in engine technology, reduced maintenance requirements, and unmatched fuel efficiency, resulting in exceptional environmental performance. The airplane uses 20% less fuel than today's similarly sized airplanes.
What makes the 787 so special?
The key to the exceptional performance of the 787 Dreamliner is found in a number of new technologies that were heavily researched, developed, and applied to the airplane. Modern systems architecture is at the heart of the 787's design. The team has incorporated airplane health monitoring systems that allow it to report systems maintenance requirements to ground-based computer systems. New engines from General Electric and Rolls-Royce are used on the 787. Advances in engine technology are the biggest contributors to overall fuel efficiency improvements. The new engines represent nearly a 2-generation jump in technology. New design and building processes of the 787 have added further efficiency improvements. For example, manufacturing a one-piece fuselage section has eliminated 1,500 aluminum sheets and 40,000 to 50,000 fasteners. The Boeing 787 makes greater use of composite materials such as carbon fiber in its airframe and primary structure than any previous Boeing commercial airplane. This approach offers weight savings on an average of 20% compared to more conventional aluminum designs. Modern aircraft are traditionally built from aluminum and its alloys. However, when composite materials were recently certified as durable, they were introduced into the construction of passenger aircraft in small percentages.
How much of the airplane is made of carbon fiber?
The Boeing 787 uses a relatively high percentage, nearly 50%, of composite materials, including carbon fiber reinforced plastic in its construction. These materials have a higher strength-to-weight ratio, which adds to the airplane's durability and reduces its weight. In the highly tension-loaded environment of the fuselage, it was found that using composites greatly reduces maintenance due to fatigue when compared with an aluminum structure. This type of analysis has resulted in an increased use of titanium as well. Titanium use has been expanded on the 787 to roughly 14% of the total airframe.
Titanium? Isn't that one of the elements on the periodic table?
Yes, titanium with atomic number 22 is the 9th most abundant element on Earth. It is a very strong metal, which is used in the manufacture of many types of alloys. Because of its corrosion resistance and low density, it is used in many aircraft and aerospace parts.
What about space and rockets?
Other exciting developments in aeronautics include Virgin Galactic's Spaceship One and Spaceship Two. These are high-altitude rockets designed for suborbital flights above the 100-kilometer altitude mark. In 2004, Spaceship One became the first privately funded aircraft to complete manned spaceflight. That same year, it won the Ansari X Prize, a $10 million prize for the first non-government organization to launch a reusable manned spacecraft into space twice within 2 weeks. Launched from its White Knight mothership while flying high above the ground, the rocket-powered Spaceship One and its pilot ascended just beyond the atmosphere, arced through space, but not into orbit, then glided safely back to Earth. The flight lasted 24 minutes, with 3 minutes of weightlessness. During its test program, Spaceship One set a number of important aeronautical firsts, including first privately funded aircraft to exceed Mach 2 and Mach 3, first privately funded manned spacecraft to exceed the 100-kilometer altitude, and first privately funded reusable manned spacecraft. Virgin Galactic has upgraded to Spaceship Two, helping to pioneer a new age of commercial spaceflight.
Whose rocket is that?
On May 31, 2012, Space Exploration Technologies, also known as SpaceX, made history when its Dragon spacecraft became the first commercial vehicle in history to successfully dock at the International Space Station. Previously, only 4 governments, the United States, Russia, Japan, and the European Space Agency, had achieved this challenging technical feat. The Dragon is a reusable spacecraft developed by SpaceX, an American private space transportation company based in Hawthorne, California. The vehicle was grappled by the station's robotic arm and was then pulled in by Dragon's passive common berthing mechanism, successfully attaching itself to the orbiting laboratory. All this was made possible by aeronautical engineers and scientists.
What kind of jobs are in aeronautics?
Many different careers exist in aeronautics, such as pilot, engineer, research scientist, material specialist, and aeronautical technician.
Jobs in aeronautics sound awesome!
Yes, they can be very exciting. Aeronautical engineers research and develop different types of aircraft. Using advanced computer software, they design new craft, create detailed schematics, and conduct simulated test runs. Aeronautical engineers work in many different settings, including military agencies, government air and space programs, and private aircraft manufacturing plants. Many aeronautical engineers specialize by working with certain types of aircraft or particular internal flight systems. Some professionals design commercial jetliners, while others conceive plans for new helicopters and passenger planes. A military aeronautical engineer may develop manned or unmanned planes designed for combat, special operations, or recovery missions. Regardless of specialty, aeronautic engineers play a critical role in the aerospace and aviation industries and will continue to develop new technologies for use in aviation, defense systems, and space exploration. During the past 100 years, aeronautical pioneers have revolutionized our world and made air travel a safe and necessary means for the transportation of goods and people.